Hello Mindsetters, and welcome to today's Grade 10 Math Show. Today we have a special revision lesson on trigonometry for you. We have selected highlights from lessons shown early in the term to help you revise. You can download the notes for today's show from learnextra.co.za/live. Now it's time to get on with today's lesson. Please post your comments and questions on our Facebook page, facebook.com/learnextra, and on Twitter @learnextra, so we can help you with your revision.
Okay, and we're going to quickly go on to our first example. So here we're given the following results for a class test, and the test is out of 20 marks. Okay, they want us to calculate the measures of central tendency, the mode, the mean, and the median. Okay guys, so what's very, very important when you have, this is discrete data. As you can see, everything has individual or discrete numbers. Okay, it's integer values. When you have a set of discrete data and you need to work out your measures of central tendency, you need to make sure that your data is ordered. Ordered means you're going from smallest to biggest, so you're going in ascending order. Okay. So what we've done here is we've got a set of data that's ordered. It's got 10, 11, 11, 12, 12, 12, 14, 16, 17, 18, 19, 20, so on. So, first question, let's find the mode. All right. Now remember, your mode, that's the value that occurs most frequently. So it's most often. Okay, so now when you've got a nice ordered set of data, you can simply look at the data and then see what your mode is going to be. Now, if we look at our data, we see that we've got 3 sets of 12, or 3 counts of 12. 3 people got marks of 12 out of 20. And then we also see 3 people got marks out of 14. If we go further into the data, we see that 2 people got 18 out of 20. And 2 people got 11 out of 20. Okay, so the mode is the value that occurs most often, but here you see you're sitting with 2 sets of values that occur most often. And that's 12 out of 20 and 14 out of 20. So when there's 2 things that occur, or 2 sets of numbers that occur the same number of times, then your data is said to be bimodal. And your modes are then 12 and 14. So there's 2 values that occur most often, and those values are 12 and 14. Okay, let's look at the mean. Right, so remember, for the mean, you use the symbol x bar to represent your mean, and you find it by adding all of your values together and then dividing by the total. Okay. So, all our numbers together, so we've got 10 plus, we've got 2 sets of 11, so I'm going to say 2 times 11 plus, we've got 3 sets of 12, so it's 3 times 12 plus, we then have 3 sets of 14, so we add that up 3 times. Then we've got a 16, and we've got 17, and I'm just going to continue it underneath it, plus 18, we see there's 2 sets of that, plus 19, and then someone who was very, very smart got 20 out of 20 for that test. And we divide the whole thing by the total number of pupils in the class, which was 15. Okay, and that's going to give us our mean, or the average for the test. So it's a way that you can work out if you're doing quite well or if you're not doing too well in your test. Compare your mark to the average. Okay, so let's do that. So we've got 10 plus 2 times 11 plus 3 times 12 plus 3 times 14 plus 16 plus 17 plus 2 lots of 18 plus 19 and then plus 20. We get that total value. We divide that by 15 and we see that our average is 14,5. Okay, so 14.5 was the average mark for that test. Okay, obviously if you did better than 14.5, you were above average in this test. Okay, next they ask you to work out the median. Now remember the median, alright, let's just get that back up there. The median is the middlemost value. So it divides your data into two equal halves. So what sits right in the middle? In this case, because we're dealing with 15 numbers, okay? Now if you've got 15 numbers, it means that there will be an exact midpoint. All we do is we count how many numbers to the left, how many numbers to the right. So for example, we go 1, 2, 3, 4, 5, 6, 7. All right, and then we want something, we will need to have a middlemost number, so there needs to be 7 numbers after that. 1, 2, 3, 4, 5, 6, 7. So there we go. We divided the data into two equal halves. All right. And so our median sits right in between those two equal halves. All right. So therefore, your median that divided your set into two halves, your median was 14. Okay, now what happens with groups data, and this brings us on to what we're going to look at now, is that whatever sets of data you had have now been ordered and they have been paired and grouped into a frequency table. Now remember, a frequency table is set up so that you get the frequencies on one side of the table, and then you get your inequalities or your intervals on the other side of the table. So if you have a look at your table now, we'll see in question 2, we are given that the mass in kilograms of 16 bodybuilders is shown. So in fact, if we're talking about mass, it is in fact continuous data, because remember, if you're measuring your weight, you can be, for example, 50,2 kg. So therefore you are measuring, so therefore we're looking at mass. It is continuous data. It's continuous data that has been grouped into a frequency table. Okay, in your frequency table, the one side of the table will give you your interval. The other side of the table will give you your frequency. All right. But one thing you need to remember when you're dealing with a frequency table that has been grouped like this, when you're working out the mean, the median, and then later on the mode, you can only work out estimated values. Now guys, the reason for this is, remember, if you're going to take values and you're going to group them, all right, so if you look, for example, at the interval, x is where x is the weight, is less than equal to 155 kgs, but greater than 150 kgs, we've obviously lost some values in that interval. So we don't know if the person was 151,5 or if they were 151. We've lost discrete values. So that means that we're only working out an estimated mean and an estimated median. So we're saying which interval does it lie in, we look at the frequencies, and then we work out each of the different measures of central tendency. All right, so let's have a look at how we're going to do this question. Okay, so the first one, we need to work out the estimated mean. Okay, as I said, estimated because we have now grouped this table together. So, in order to work out your mean with grouped data, all right, remember this table is your frequency. If you add all these numbers up, it will give you your total frequency. So 3 plus 4 is 7, 7 plus 7 is 14, 14 plus 2 is 16. Okay, it should obviously add up to the number of bodybuilders. Okay, because they told us there were 16 bodybuilders. So that frequency will give you your total number of bodybuilders. Okay? When we're working out the mean for a grouped set of data, we need to work out, and I'm going to try and add it on this table. We need to work out, okay, and if I can't get it in here nicely, then I'm going to have to go below and try and redraw this table, but let's try. Okay, so I'm just going to include another little section to this table. All right, and I'm going to have two columns here. Okay, and we'll go across each of them. So why do we need this? Because we're dealing with frequencies, we need to work out the midpoint of each of these intervals. So I'm going to call the midpoint x. And then we work out the frequency times by your midpoint. Okay, and this is how you work out your mean, your estimated mean for a grouped set of data. Your mean x bar is equal to the sum of the frequencies times the midpoint of the intervals divided by n. Okay, so you see it's slightly different from your discrete data where we just said it's the sum of all the values divided by n. Here we've got to actually take the frequency, times it by the midpoint x, and then, in fact this should be a big X, and then we divide the whole thing by n. Right, so the first thing we need to work out is the midpoints of each of these intervals. Okay, very simple to work out the midpoints. All we do is we take our two end values, add them together, and then divide by 2. So we add those values together, 150 plus 155, divide by 2. 155 plus 160, divide by 2, and so on and so on and so on. Okay, that will give us the midpoint of each of those intervals. Okay, so let's call up our calculator and let's get cracking. All right. So, the first one, we've got 150 plus 155, and we're going to divide that by 2. So our first midpoint is 152,5. So that's what we put in the midpoint column. Okay, so 152,5 is our first midpoint. We then go to the next one. It's 155 plus 160. And yes, guys, you do have to show out all of these workings. You get marks for this. So just working it on your calculator, because your calculator obviously can work out the midpoints and all of that for you, but you need to show all of your workings. So this one was 157,5. Okay. The next one, we've got 160 plus 165 divided by 2. And here you've got 162,5. And then in the last one, we're going to take 165, add 170, and then divide that by 2. So we get 167,5. Alright, once you've got all of the midpoints, you now need to times the frequency by that midpoint, and then we're going to add that all together. Right. So the first, we'll start from the bottom and go up. So we've got 167,5, and our frequency for that last midpoint, our frequency was 2. So we're going to say 167,5 times 2, and we get 335. Okay, so we're going up, remember. The next frequency is 7, so we're going to say 7 times 162.5, and that gives us 1,137,5. So it's 1137,5. Right, and you just go up the table doing exactly the same thing for each of them. The next one, it was 157,5 times by 4, and that gives us 630. And then the first one, 152,5, and we times that by 3. And we get an answer of 457,5. Alright, once you've got this column, your frequency times your midpoint, you now need to add all of these values together and divide it by n to work out your median. Okay, so it's going to be 457,5 plus 630 plus 1137.5 plus 335 divided by the total, which was 16. Okay. Right, let's do that. Okay, so it's 457.5 plus 630 plus 1137.5 plus, what's the last one we've got there? 335. Right, get that total. Divide that by 16. So 160, see, we've already got an equal sign. 160 is the average weight of all of these bodybuilders. Okay, so the weight started at 150 and went all the way to 170, but your average weight is 160 kilograms. The next thing we need to work out is the estimated median. Now remember, the median is the middlemost values. So we've got 16 bodybuilders that we are looking at. So we know that the middle value is going to lie somewhere on the 8th data set, at the 8th data point. How did I get that? I simply took 16 divided by 2. So it's going to lie somewhere between the value of 8 and 9. Okay, the 8th and 9th value. So what we would do is we simply look, we add our frequencies, and we see where the 8th value would lie. Which interval will it lie in? So 3 plus 4 will give me 7. So over there I'm already up to 7. And then 7 plus 7 will give me 14. Okay, so all I'm doing here is I'm adding the frequencies. All right. And so in interval 2, so that's between 155 and 160, we are only up to 7 bodybuilders. So therefore we know that the 8th one must fall in the very next interval. Okay, because obviously if 7 ends up to 160 kilos, then 8 must fall into the next interval. So therefore our estimated mean is going to be in the interval 160 to 165. Okay, so that's going to be our estimated median. It's going to lie in that interval 160 to 165, and all we do is we're going to say, well, if we're looking for the 8th value, we're starting from 160 to 165, so therefore the estimated median is going to be in that interval. Okay, so it's in the interval 160 to 165. All right. Okay, then the next one says, where is the modal interval? Now remember, your modal interval is where the most amount, or where you get the most repetitions. Now if you look at your frequencies, we've got 3, 4, and 7. So we've got most of our repetitions in this interval, in the 3rd interval. So therefore our modal interval is going to be 160 to 165. So our modal interval is x is less than equal to 165 but greater than 160. Okay, so that's our modal interval. Okay, and remember, because we're dealing with grouped data and we're dealing with continuous data in this case, we can't tell exactly what that mode is going to be. We just know that it's going to be in the interval, in the 3rd interval between 160 and 165. And we know that because we see that the most number of values occur in the 3rd interval, because we've got 7 values in that interval.
Okay guys, I hope you are enjoying this revision session. If you are struggling and need help, remember to post on the Facebook page, facebook.com/learnextra. Now it's time for a break, so don't go away. We'll be right back. Welcome back, guys. I hope you are getting into the idea of revision. Please let us know how you are doing. I'd love to chat to you on Facebook and on Twitter. But enough of the chat. Let's get back to revision.
Okay, so here this one is maybe a little bit more complicated, but it's more of looking at how do we find angles. So we looked at one where we actually had to draw the question. Now what happens when they give you the diagram, there's more than one triangle involved? How do we find an angle in that case? All right, so let's have a look at what we've got in our drawing. We've got triangle ABD, they've asked us to find angle ABC, which we'll call alpha this time. Alright, and as you can see, we've got more than one triangle. We've got triangle ABC, we've got triangle ABD, and we've also got triangle ACD. So there's quite a few triangles to work in. But we are looking for angle B, or angle alpha. So how do we go about it? Well, always with your 2D problems, we're going to start in the triangle with the most information. In this case, that happens to be triangle ADC. Okay, why do I want to start there? Well, if we're looking for alpha, right, and we look in triangle ABC, the only thing we have is the opposite side. So that's not really going to help us, because if we're trying to find an angle, so if we're looking for an angle, right, and we're using our basic definitions of our trig ratios, we need to have two sides. You have to be given two sides to find an angle in a 90-degree triangle. All right. So if we look at triangle ABC, well, we've only got one side. Then if we look at the big one, ABD, there's similar problem. All we've got is BD. So how do we find alpha? Like I said to you, we need to work in the triangle with the most information. So we work in triangle ADC. How is that triangle going to help us? Well, guys, you'll see that if you look at triangle ADC, you have an angle and you have a side. All right, so you have the opposite side, you have the angle, and we know that in the big triangle ABD, we've got that side DB is actually 17. So now if I knew what this is, what side DC is, then all I would do is simply subtract side DC from 17, and that will give me BC. Okay, because remember, BC plus DC will give us the side BD. So obviously, if we know that BD is 17, right, and we work out what DC is, then we simply subtract to get BC. All right, so we're going to work in triangle ADC. Okay, so in triangle ADC, we've got the angle 41 degrees. Remember that AC is perpendicular to DB, so therefore this angle DCA is also 90 degrees. So I've got the opposite side, and I'm looking for DC, which is the adjacent side. So I say in triangle ADC, tan of 41. Why tan? Because tan is opposite over adjacent. So tan of 41 will be equal to AC over DC. But we know that AC is in fact 9. So if I'm looking for DC, what I need to do is to cross multiply. Okay, so we cross multiply to bring DC to the numerator. So we'll get DC times tan 41 is equal to 9. All right. We're looking for DC, so we need to divide both sides by tan 41. So DC will be 9 divided by tan of 41. And that's going to give us, let's have a look, 9 divided by tan 41. And that gives us 10,35. All right. So now that we know that DC is 10,35, we can work out BC, because BC is simply going to be, let's just go back to our question there, BC is simply going to be 17 minus 10,35. So BC, 17 minus 10.35, and that's going to give us let's have a look. So it's 17 minus that, and we get 6,65. All right, so BC is 6,65. So now that we've filled that in, guys, have a look at the diagram and see what we've got. I'm just going to raise that so it makes it a little bit easier for you to see. We know that BC is 6,65. We know that AC is 9. So in triangle ABC, I can work out alpha because we now have the opposite side and we have the adjacent side. So you can see that in triangle ABC, you now have two sides. So we've got two sides in our 90-degree triangle. That means we can use our trig ratios and work out the angle alpha. All right, so let's quickly do that. I think we should quickly finish this question before we take a quick break, Abraham. I know that you want to go for a break, but guys, we're going to quickly finish this off. It's going to take 1 second. So we're going to rewrite this and say, well, tan of alpha is going to be opposite, which is 9, over adjacent, which is 6,65. So therefore, I use my calculator and work out alpha. All right, remember we're working out an angle, so we start with shift, and our ratio here is tan, and we've got 9 divided by 6.65, and that gives us an answer of 53,54. So let's have a look at our first question in this section. So we are given a point P, which is minus 3, 4. They tell us that that's a point on the Cartesian plane. Angle XOP is equal to theta, and X is a point on the x-axis, without using a calculator. And that's very important because when they say without using a calculator, you're obviously going to get no marks if you do use a calculator. And they say determine the value of, and they give you ABC. All right, so very important, guys. In this section, you'll say, but how am I going to use a calculator? I need to work out fractions. Yes, if you need to add your fractions and that on your calculator, you can. But if you're going to try and work out the value of theta and then plug that value of theta in to give answers and ratios for each of these questions, you're not going to get any marks because that's not how we want you to approach this kind of question. So how do we want you to do it? Well, I'm going to show you now. All right, so we've got P that's given as minus 3, 4. And we know that XOP is equal to theta. So we're going to draw a diagram. Remember, it's on the Cartesian plane. So let's first draw our Cartesian plane. Okay. And they tell you that the point P is minus 3 and 4. So minus 3, 4, that's going to land you in the second quadrant. So X is minus 3. All right, so we're going to say that's somewhere there, and y is 4. We're going to call that point P, and I'm just going to draw a line from the origin to that point P. Okay, so that's what our diagram's looking like so far. That point here, the blue point, is point P. They tell you that XOP, so this is your x-axis, remember, XOP is equal to theta, so that's your angle there. And without using a calculator, determine the value. So without using a calculator, we need to drop a perpendicular from the point P to the x-axis. So that's going to be 90 degrees with the x-axis and the line from point P, so from your ray, all right? And we know that P has coordinates minus 3, 4. So that tells us that the x distance in this triangle that we've drawn, that's 3 units, okay? And then your y distance to that point P is going to be 4 units. All right. The first thing we should do before we even try to answer these questions, guys, is to first work out the length of the radius. So we need to work out OP, and because we got this Pythagoras triangle, we just use Pythagoras. So we can say, well, x squared plus y squared is equal to r squared in that triangle. We know that x is 3. We know that y is 4. Alright, so we're simply going to simplify. So we get 9 plus 16 is equal to r squared. Therefore, r is going to be the square root of 25. Alright, and the square root we're interested in is the positive square root, because our radius, it's a length, it will never be negative. So therefore, the radius is just 5 units. Okay, so that distance OP is 5 units. So once you've now drawn this diagram, okay, so you've got your ray in the second quadrant, we've dropped a perpendicular from that point P to the x-axis, and we've got the distance of the x, the y, and the radius, we can now answer the questions. Okay, so the first one says, find cos of theta. We're going to go straight to our diagram and read it off. So cos of theta is, if you're using, guys, and let me show you this, I've shown this to you before, but if we're using x, y, and r, x is the same as adjacent, y is the same as opposite, and r is the same as hypotenuse. Why do I bring that up? Because some people only remember it as cos is adjacent over hypotenuse, but they correspond in this way. Okay, so if you know that cos is adjacent over hypotenuse, a is the same as x, so therefore this would be x over hypotenuse is the same as r, so it will be x over r. Okay, and it works in the same way for sine and for tan. So cos is x over r, so I go to my diagram and I say that's going to be x is 3, r is 5, so cos will be 3 over 5. Alright, next one, part B, we asked to find 3 tan theta. So tan we know, again using our diagram, tan is y over x, so y over x, or opposite over adjacent, so it's going to be 4 over 3, and we simplify that, the 3's cancel, so we just left with 4. And then the last one, they ask us for a half of cosec theta. So a half cosec theta. So here we've got the reciprocal ratio. Okay, now you would have seen this before. Cosec is actually the reciprocal of sine. So sine of theta is y over r. So cosec is going to be the inverse of that. It's going to be r over y. Let me quickly remind you while we're on this point of your reciprocal ratios. Alright, so cosec we know is the same as 1 over sine. So cosec is 1 over sine theta. Sec of theta is 1 over cos theta, and cot of theta is 1 over tan theta. Alright, so it means that if sine is, well, since sine is y over r, to find cosec, I simply invert that ratio. So therefore cosec of theta is going to be equal to r over y. Alright, so that means when we go to our diagram, we now take the ratio for r, which is 5, over y, which is 4. Okay, and that's going to give me 5 over 8 when you simplify. Okay.
Now it's time for a break, so don't go away. We'll be right back. Welcome back from the break. I can't believe that spring is here and soon it will be time to plan for your final exams. Don't stress, exam school is coming in term 4. We'll be here to support you all the way. But for now, let's get back to today's revision lesson.
Alright, so let's go straight into some questions using the midpoint theorem. We are asked to find x and y, and we've got a little diagram that's drawn for us. Alright, So if you have a look in this diagram, we've got no y, we've only got x. Okay? So using the midpoint theorem, guys, you'll see we've got a few things going on here. We know we don't have sides in that, but we can see these two equal signs here. That tells you that this is the midpoint of this let's call this A, B, C, and let's call that D and E. All right, so D is the midpoint of AB, and E is the midpoint of BC. Okay, now how do we go about solving this? Remember, we're looking for x. Now, since we know that D is the midpoint of AB, and E is the midpoint of BC, because that's given to you, all right? So we can say, therefore, ED must be equal to a half of AC. Now remember, with geometry, it's very, very important when you set out your proof to give a reason. So the reason I can say ED is equal to a half AC, we can say that's because of the midpoint theorem. Okay, you need to give a reason that backs up your statement. Okay, so this is our proof. So we know that ED is equal to a half of AC. Now, we don't have any other information. We've got side AB and we've got side BC. We don't have side AC. But if you notice, in triangle ABC, we have a 90 degree. So that means we're dealing with a right angle triangle. So therefore, we can say in triangle ABC, from Pythagoras, we know that AC squared is equal to BC squared plus AB squared. And the reason there, that's just straight from Pythagoras. All right, we know that BC is 8, so we're going to have 8 squared plus 6 squared. 8 squared is 64 plus 36, and 64 plus 36 gives us 100. So therefore, AC will be the square root of 100, and the square root of 100 is 10. Okay, so therefore AC is 10 units. So we know now that the whole length of AC is 10 units, but remember we're looking for ED. So how do we find ED or X? Well, we know that X is going to be equal to a half of 10. And the reason for that, again, is the midpoint theorem. So therefore, X is going to be a half times 10, which is 5. All right, so we had to state a few things first here. We had to say, since this point D was the midpoint of AB, since E was the midpoint of BC, and we know that if that's the midpoint and that's the midpoint, then from the midpoint theorem, DE must be parallel to AC. And we also know that DE must be equal to a half AC. So those are just concepts that came straight from identifying the midpoint theorem. Once you've got the midpoint theorem, then it's simply a matter of application. All right, let's have a look at another example where we need to use the midpoint theorem. Okay. Again, we're looking for X and Y. All right, so if you have a look at this diagram, PST is your triangle. We've got point Q is the midpoint of PS, and we've got R is the midpoint of PT. Okay, so we also know that QR will then be parallel to ST, but how can we state that? Well, it follows from the midpoint theorem. So let's set this up. We can say, since Q is the midpoint of PS and R is the midpoint of PT, right? Therefore, QR will be parallel to ST, and QR will be equal to a half of ST. And all of this follows just because it is the midpoint theorem. Okay, so that comes straight from the midpoint theorem. Okay, now remember, because we have the length of QR, we know that QR is 14, so therefore ST, so we can go from that step. We'll say, well, QR is 14, and that's going to be equal to a half of ST. And remember, ST was given as X, so 14 is equal to a half of X. So therefore, X must be equal to, we divide both sides by a half, 14 divided by a half, tip and times, so we get X is equal to 28. So therefore, ST is equal to 28. Okay, now if we're looking for angle Y, all right, and this is why I stated both of the deductions from the midpoint theorem, because if you're looking for angle Y, we're going to use the fact that QR is parallel to ST. How is that going to help us? Well, angle S is going to be equal to angle PQR. All right, I've marked them on your drawing. So PQR and angle S, which is why they're going to be equal to each other. And the reason there, hopefully you can all recognize it by now, that's corresponding angles. And that's because QR is parallel to ST. So angle S is equal to angle PQR. Can we work out angle PQR? All right. Well, if you look at your diagram, you see that you've got angle P is 40, angle R is 60. Therefore, using angles of a triangle, you can work out angle PQR. So angle PQR is going to be 180 minus angle P plus angle R. So that's going to be 180 minus P is 40, R is 60, so it's 180 minus 100. So therefore we get angle PQR is 80 degrees. So that's 80 degrees there. So therefore, since Y or angle S is equal to PQR, therefore Y will be equal to 80, and that's because it was corresponding with angle PQR. So this is question 4. They say given parallelogram ABCD with AE and FC. So that's just, AE is just a line, FC is just a line. They also tell you that AE bisects angle A. Bisects, remember, cuts in 2 equal bits. And then FC bisects angle C. So FC also cuts angle C into 2 equal bits. But then ask you to write down all the interior angles in terms of Y. Okay, so let's have a look at that part first before we look at part B. And I just remind you of what the properties of a palm are. All right, so the big piece of information they've given you here, well, 2 big pieces. They tell you that the big shape ABCD is a palm. So there's lots of things you know from that. We know that that means that AB is parallel to CD. How do we know that? We didn't make that up. It's one of the properties of a palm. BC is also parallel to AD. Okay, we also know that the whole length of AB is equal to CD, and the whole length of BC is equal to AD. Okay, all follows from properties of a palm. They tell you that FC bisects, so it bisects, which means cuts in 2 equal pieces. So therefore, if FC bisects angle C, so if we call this C1 and C2, well then C1 will be equal to C2. Similarly, they tell you that AE bisects angle A. So if we call this A1 and A2, and here they tell you that A1 is Y, then A2 is also going to be Y. All right. And they ask you to write down all the interior angles in terms of Y. So let's get started. Okay. First one that we can do quite easily is we can say, now if you're going to write A1 and A2, make sure on your diagram sheet you indicate which one is A1 and A2. Otherwise, name your angles with the letters. So, for example, this A2 would be BAE or FAE. All right, I'm going to use A1 and A2 because it's obvious from the diagram. So the first simple one is angle A2 is equal to y. Remember, statement has to be followed by a reason. The 3 upside down triangle dots, that means since. So A2 is equal to y since it was given that AE bisects angle A. All right, so A2 is equal to y. Then we look at the whole of angle C. Now remember, ABCD is a palm, okay? And in a palm, we know the opposite angles are equal. So angle C is equal to angle A is equal to 2y. Why is it 2y? Because A1 plus A2 is equal to 2y. So therefore, angle C is equal to A is equal to 2y. Reason, opposite angles of palm. Okay, and I'm just abbreviating there to palm. So C is equal to A is equal to 2y. But we know that that line FC bisects angle C. So we know that angle C is made up of C1 plus C2. And if they're both equal to 2y, then we know, bisecting it, we're going to get C1 is equal to C2 is equal to y. All right, so therefore these two little pieces here are also going to be y. Okay. All the interior angles, so we've only done A and C, we need the rest of them. Angle D is going to be 180 minus 2y, and the reason for that is going to be co-interior angles. So angle D, so A plus D is equal to 180. That's co-interior angles. So therefore, we got that D is equal to 180 minus 2y. All right, we can get B by saying B is equal to angle D because of opposite angles of a palm. So therefore, B is going to be 180 minus 2y. All right, so we've got that one. Okay, but we're not done. So we've only got the interior opposite angles. We also need all these little pieces in between. Okay, so angle E, if we call this one here angle AED, that's going to be equal to y. And the reason angle AED is equal to y is because of alternate angles. So it's equal to A2 because of alternate angles. All right, so if we look at your Z shape, there we go. So angle E is equal to angle A2 because of alternate angles. All right, this angle here, angle A, well, what do we want to call this? AEC, that's going to be 180 minus y because of angles on a straight line. Okay, similarly, we can find that angle F1, if we call it that, is going to be y because of alternate angles. And then the one on the other side of it is going to be 180 minus y because of angles on a straight line. Was it necessary to find all of these angles? Absolutely. And the reason for this is with geometry, a lot of the times you'll find that one question leads you on to the next one. So yes, we did have to find all of these angles because as you're going to see in the next question, we're going to use it. All right, and the next question says, prove that AFEC is a parallelogram. So the little piece in the middle, we need to prove that it's a palm. Now guys, before you can even try or attempt to prove that it's a palm, you need to remember the properties of a palm. Because obviously, if you don't know the properties, then you can't prove that it's a palm. It's as simple as that. Okay, so that's the little orange piece that we're trying to prove is a palm.
We've come to the end of today's show. Thanks for joining us and for chatting to me during the show. Remember to visit our website, learnextra.co.za/live to get the notes and to watch the videos from the term. If you are stuck on any questions, make sure you post them on Helpdesk at learnextra.co.za/helpdesk. From all of us at Learn Extra, have a great September holiday and join us again from the 30th of September for Term 4.